Regarding boundary value analysis, this is a quite common technique because it tests the behavior at the edges of each equivalence partition. So the idea is to use them as complementary to one another. So boundary testing is one of the aspects that some of you as programmers have considered when seeing that division of partitions. For instance, the maximum and minimum values of each partition are the boundary values, and they should also be tested because they are very prone to errors. As programmers, and looking at the requirement that we have just seen for the equivalence partitioning, you are considering that all of that rules that make up the feature for the requirement to provide an adequate answer to the requirement imply a set of ifs that compare a value that is introduced by the customer, that is the age, and the age should be tested against all of that values that are already known. So there are a lot of less than and greater than that should also include an equal sometime along the code. And that equals that should be in the code are the responsibles for the defects that sometimes occur in some software products. So boundary value analysis, such as the equivalence partitioning technique, can be applied at all test levels. A boundary value for a valid partition is a valid boundary value, and a boundary value for an invalid partition is an invalid boundary value. Tests can be designed to cover both valid and invalid boundaries. When designing test case, a test for each boundary value should be chosen. This technique is relatively easy to apply, and its defect-finding capability is high. Detailed specifications are helpful in determining the interesting boundaries. So, if you have requirements, if the requirements are pretty detailed, you have a lot of material to work and use this technique. This technique is often considered as an extension of equivalence partitioning or other black box test design techniques. It can be used on equivalence classes for user inputs and, for instance, time ranges, whenever you have to introduce a time period with a start date and an end date, okay? When you are trying to, once again, test timeout values so that you can produce a non-functional requirement and you can be sure that you have the performance of your system attained, okay? And another quite common example is to test the boundaries of arrays and tables, the table ranges, because when you have, for instance, an array that starts at index 0 and the last position of that array is the size -1, you should test the array if it can accommodate values at 0, if it can accommodate values at the middle, and if it can accommodate values at the last position. And you should also test the invalid indexes to access the array. For instance, using -1 because it's an invalid position in the array, and position that equals the size of the array that is also an invalid position of the array. Let's take a look at what happens when we apply boundary value analysis at the requirement that we have already seen. So the partitions are established, and then we set and we add a couple of more test cases related to an invalid boundary at -1, a valid boundary at 0, a valid boundary at 16, a valid boundary at 17, and another at 75, then here at 76 and 999, and then an invalid boundary at 1000. This adds up 1, 2, 3, 4, 5, 6, 7, 8 additional test cases besides the already test cases that we had 1, 2, 3, 4, 5 for each test partition.